Now children, in this video, we will study about dipole moment. What is dipole moment? It's a measure to express the polarity of covalent compounds, or say the polarity of covalent compounds is expressed in terms of dipole moment. What is this dipole moment? It is shown by the sign symbol mu. It is the product of magnitude of charge present on either of the two combining atoms and the distance by which the two atoms are separated in the molecule. The product of magnitude of charge present on either of the two atoms, like here we have AB, the charge whatever this has, the same will be here. So either of the charge Q and the distance by which they are separated, R. R is the distance. So mu is equal to Q, charge, into R, distance between the two through which they are separated. It is shown by an arrow with a cut here, with a plus sign here, you can say, which points from positive to negative, or say which points from less electronegative atom towards more electronegative atom, or relatively electropositive atom towards relatively electronegative atom. You can say like this, means from positive to negative, positive to the side which is more negative. Its unit is debye, shown by D. So 1 debye is equal to 1 into 10 to the power minus 18 ESU centimeter. You just have an idea about it. Now, it's a vector quantity, children. The net mu, the net dipole moment of a molecule is the resultant of the dipole moments of all the polar bonds present in the molecule. This being a vector quantity, so finally you get the result, the sum of all the vectors through which you were measuring dipole moment. So it is the net dipole moment is the resultant of the dipole moments of all the polar bonds present in the molecule. We find out for each and every bond, and then its sum of the vectors we add up and we find out the value. Now, children, they will not ask you exactly to calculate, but we have to know some standard values. I tell you, a molecule will have at least two atoms. Forget about your inerts. Normally, any molecule will have at least two atoms. They can be like similar atoms or they can be dissimilar atoms. Children, if the molecule is having similar like atoms like H2, O2, Cl2, in that case, electronic will not be either towards this H or that H. No, both are same atoms. So in all those molecules, the value of dipole moment will be 0 because none of them will be having any charge. The charge comes into existence only when we have heteroatoms. So those molecules like your say H2, O2, Cl2, etc., those will have mu is equal to 0. They will all have mu is equal to 0. All those atoms. There will be no polarity at all. Then comes if we have heteroatoms. Diatomic molecules with heteroatoms, they will never have mu is equal to 0. What value we don't know, but the value will not be 0. For example, and then children, what happens? Suppose these atoms were AB, HCl, HBr, HI, HF, whatever. So higher the difference of electronegativity, greater will be the mu. Suppose I have HCl and HF. HF will have the greater value of mu or say dipole moment than HCl. So top will be HF, then HCl, then HBr, then HI. So likewise, you can have an idea about the dipole moment. Frankly speaking, we just have to have an idea, children. We don't have to go for the exact values. So firstly, if there were atoms like this, identical atoms, there's no polarity, mu will be 0. Certainly, because polarity of covalent molecules is expressed in terms of dipole moment. So when there's no polarity, totally a non-polar bond you also see. So there will be no value of dipole moment and mu 0. So when we have heteroatoms, in that case, mu will never be 0 and greater the difference of En, higher will be the value of dipole moment. Then if we have the molecule of the type AB2, example BeF2, CO2, etc. You see BeF2, so AB2 or CO2. This kind of linear molecules, you see, center atom and the two neighboring atoms will be farthest apart. So if they are farthest apart, they will be only in this position and the molecule will be linear. So linear molecules, when we have same atoms here, example of the type AB2, they will all have mu is equal to 0 because otherwise also you see it gets cancelled. Whatever value was here, same here got cancelled. CO2, whatever was here, same here got cancelled. So mu 0, mu 0. So molecules which are linear molecules of the type AB2 having same atoms, not that BeF and then Cl. In that case it will not be there. The moment you have a heteroatom means I'm talking of these atoms. AB2 types. Like suppose I have ABC. There are 3 atoms. AB2, 3 atoms. But then all are different. No. A and B should be same on both the sides. They should have this geometry. Suppose it is F and here it is Cl. No. In that case it will not be there. So there should not be heteroatoms here. Like it is C double bond O and if you make this side C double bond S. No. Mu will not be 0 because this vector will not get cancelled. So remember, being a vector quantity, it has to be added. So what all value was here, it is here. Suppose it was Cl, then the whatever value of this vector will be there. It cannot be same as that of between B, E and F. So hence, it cannot be 0. So please understand the atoms which are at the edges or the corners, they should be same. Then only the mu will be 0. I again repeat, if it is C double bond O, it gets cancelled. But if it is S, it will go this way. But we know the value of this vector and this vector cannot be same if it is S. Hence will not get cancelled. So this will have 0, this will have 0. But the moment we have one atom different on either side, either here or here, any one side. One O is here, it becomes S or whatever. In that case, mu will not be 0. It will be 0 only when it gets cancelled. You see, this was value here, this was value here. Because it is from positive to negative, this value got cancelled. Then if we have the molecules of the type AB3. Again AB3 means children, A in the center and 3 B's at the corners. Say it was this B in the center or say it is AB3. So I took example as BF3. BF3 is an example of this type, AB3. So B I have taken here center and these 3F molecules are here, atoms are here. This value here, you know, the value will be from positive to negative. So from boron to fluorine, boron to fluorine, boron to fluorine. So this value and this value of one vector was here and this is the resultant vector. This is the resultant vector of these two and this is here. Finally, it will get cancelled. And that's how it is there. Right, children? So these two will get cancelled. This is the resultant vector of these two. This is this side. Hence, it will get cancelled. You can understand that much basic math and physics, you know. Now come to other molecule of the same type, AB3. Here we have ammonia, NH3. But children, we know one thing, that in ammonia molecule, at one point on N atom, we have a lone pair of electrons. So here children, the shape is not like the way it was there. It is tetrahedral shape. Tetrahedral. 1, 2, 3, 4 corners. Out of those 4 corners, 3 are occupied by H and 1 corner is occupied by this lone pair. With the result, the actual shape is not even tetrahedral. It became pyramidal. So when we had pyramidal shape, it was only possible when the one position of this kind of molecule was occupied by a lone pair. In that case, what happens? H2N, because N is more electronegative than H. So it points here, it points here, it points here. Resultant is somewhere here. And now N towards more negative electrons, what to say? It gets added up, hence the value. This mu is not 0. This is for ammonia. Mu is not 0. What value is there? We are not concerned. Not to worry. But mu is not 0. So I got the point. All linear molecules like example BeX2 etc. they have mu 0. This kind of molecules have got 0. H2O is angular because we know in H2O molecule there are two lone pairs, and once the molecule has lone pairs, children, normally you will find the value of mu is never 0. So in simple words, remember ammonia, yes, 3 H atoms were there. It was of the type AB3, but we should not forget that at one position we have got lone pair. Hence, the picture is not same like we have example BF3 where there is no lone pair. When there was no lone pair, there was no repulsion, there was no other problem which could not make mu 0. But once we have lone pair, things change. The shape of the molecule changes. So ammonia, because of one lone pair, you would say mu will not be 0. And water molecule, you know, it has got not one but two lone pairs, mu is not 0. Actual shape of water is angular. Actual shape of ammonia is pyramidal. And for your information, children, you see they all have 4 positions in a structure. Like methane, C in the center and 4 points HH. Ammonia, N in the center and 3 points H. 1 point occupied by lone pair. Water, 4 points like CH4, but at 2 points H atoms, at 2 points lone pair. With the result, in this case, CH4, where all the points were occupied by the same atoms, mu got 0 because it had fixed regular geometry tetrahedral. You'll say, what is she talking tetrahedral? We don't know. Children, don't worry. This will be taken up in this chapter only in the next topic when we will do hybridization. Right now, you just think that all these atoms, molecules have one center atom and 4 positions occupied in the neighbor. Here the neighbors were all H atoms. When we have this kind of symmetry, you'll find every time mu goes to 0, dipole moment goes 0. In case of ammonia, out of 4 corners, 3 occupied by H, 1 was occupied by lone pair, hence the value of mu dipole moment could not be 0. In case of water, again there were 4 points, 2 corners occupied by H and 2 corners occupied by O. The shape in case of water became angular, or we call it bent and V shape. This again I'm telling you, we'll be doing it in the next topic. But right now remember that whenever we have the cases of lone pairs, mu will not be 0. Just in general I'm telling you, although it's not a rule, that as the number of lone pair of electrons increases, mu increases in general, it is seen. And I think at your level this will help you in solving many questions. So these were of the similar type. Methane was 0 because of the fixed geometry. All 4 points occupied by H. But here 1 lone pair, here 2 lone pairs. So its mu was not 0. All whatever value was there, I don't know. But if it is single tick, it is double tick. Means if its value is X, it is X plus something. Water has higher value of dipole moment than NH3. So children, this is all what you had to know for dipole moment. Again, a new term for you. Not that easy, but not impossible. If you will again see my video, you'll come to know. Of course, maybe you need to see twice. But children, you go through this, you do see this, and I hope the points will be clear to you. And what all points I've given you here will be sufficient for you to answer all the questions. I think this is all for today. We can stop here, and more we will take up in the next class. Please update your notes, and this video you see twice or thrice. I'm not repeating here again and again because time factor is also there to be kept in mind. Please see to this twice, thrice. Hope it will be clear to you. What all points are here? If you note down these points and try to understand those points, it will be clear to you. This is all for today. We stop here. Thank you, children.